Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain you the concept of problem solving on relational decomposition. Problem solving on relational decomposition. So relational decomposition. So generally relation is nothing but what? Table. So relation is nothing but what? Table. So in DBMS, in database management system, a relation is nothing but table. And the decomposition is process of dividing or blocking or breaking the table into different parts. So why we are going for the decomposition of the tables? So to do this all, we have to use normalization process also. So decomposition is a process of breaking the tables or dividing the tables into small parts. That is nothing but breaking the multiple tables. So see here, when a relation in the relational model is not in appropriate normal form, then the decomposition of relation is required. So for what reason we are going to decomposing the relation means, if any relation is nothing but what? If any table is not in the normal form, any table in the relational model is not in the normal form, then the decomposition of relation is required. So at that moment, what we have to do? We have to do decomposition process. So in a database, it breaks the table into multiple tables. So it breaks the table into multiple tables. So breaking a table into multiple tables, dividing the tables. If the relation has no proper decomposition, then it may lead to problems like loss of information. So if the decomposition is not done proper way, then it leads to problems like loss of information. So the problem will be loss of information. So decomposition is used to eliminate some of the problems of bad designs like anomalies, inconsistencies, and redundancy process. So like this, decomposition is used to eliminate this type of problems like anomalies, inconsistencies, and redundancy problems. So this means syntactical and semantical problems. So to eliminate this process, to eliminate these all problems, the decomposition is required. But how we are going to perform the decomposition process? In what way we can use the decomposition process to reach the relation into the normal forms? So there are two types of decompositions are there. One is lossless decomposition. Second one is dependency preserving. One is what? Lossless decomposition, and the second one is what? Dependency preserving. So let us see what is meant by how we are going to perform decomposition lossless under dependency preserving way. So lossless decomposition. If the information is not lost, from the relation that is decomposed. So when you are decomposing the table, if any information is not lost, then the decomposition will be lossless. So if the information is not lost means, then the relation is decomposed, then that decomposition will be the lossless. So at the time of decomposition process, if any data loss will not be occur, then it is treated as a lossless decomposition. So the lossless decomposition guarantees that the join of relations will result in the same relation. The join of the relation will be the result in the same relation as it was decomposed. And the relation is said to be lossless decomposition. If natural joins of all the decomposition give the original relation. So the relation is said to be lossless decomposition when we are going to say if natural joins of all the decomposition given the original relation. So at that moment we can say that what? It is a lossless decomposition. The relation is in lossless decomposition. So let us take an example here, the employees underscore department table. So the table name is what? Employee underscore department table. Employee underscore department table, which contains employee ID, employee name, employee age, employee city, department ID, and department name. So here the entity name is what? Employee underscore department. Employee underscore department is an entity. Is an entity which contains attributes or what? Employee ID, which contains attributes employee ID and employee name, the next employee age, the next employee city, the next department ID, next department name. For these all attributes, we are going to have different types of values like Denim, Alina, Stephen, Catherine, Jack, or the employee names, and there is no duplicate values also in this table. So now, if I perform the decomposition to reach the normalization, so here the employee cities will be having a duplicate values, and that means multi values. Then how we are going to perform the decomposition? So by dividing the table into two types. So the above relation is decomposed. The above relation is decomposed into two relations. One is what? Employee table, and the second one is what? Department. One is what? Employee table, and the second one is what? Department table. So how it is splitted or divided? So which contains employee ID, employee name, employee age, and employee city. Employee ID, employee name, employee age, employee city. So here the employee ID will be the primary key. It is the primary key, and it is also called as primary attribute. And other all are other all non-prime attributes. Non-prime key attributes. So that indicates that what? All these employee name, employee age, employee city are depending on the employee ID. Similarly, department table. The second splitting table is what? The second relation department, which contains department ID, employee ID, department name. So here the employee ID and the department name both are the non-prime attributes, and here department ID is the primary attribute. So the employee ID and the department name, these two are non-primes, are depending on this department underscore ID. So department ID is the primary one. So now based on that, the employee ID is depending on department ID, and employee name, employee age, employee city are depending on employee ID. So this is the way if you can decompose the table. Then if you join these two tables will be the same, will be appear. So now when these two relations are joined on the common column employee ID, when these two relations are joined on the common column employee ID, then the resultant relation will be looks like. So performing employee joins with the department, employee performs joins with the department, displays all these values. So which is same like as original table, original table. So hence the decomposition is lossless join decomposition. Hence the decomposition is lossless join decomposition. So this is the way to reach the normalization. We can use the decomposition process, but in the decomposition process we can remember that one thing: the splitted tables, that is divided tables, are joined together will form the original table values. So to understanding all these, we can use the different types of rules also. And next, second one, dependency preserving. So the first one is what? Lossless decomposition, and second one is dependency preserving. So in this, it is an important constraint of the database. It is an important constraints of the database. And in the dependency preservation, at least one decomposed table, at least one decomposed table must satisfy every dependency. So at least one decomposed table means here the two tables are there, employee table and department table. So from these two tables, at least one decomposed table will satisfy the rule of this table. So that satisfies every dependency. So if a relation R is decomposed into relation R1 and R2, then the dependencies of R either must be a part of R1 or must be a part of R2, or it is must be derivable from the combination of functional dependencies of R1 and R2. Functional dependencies of R1 and R2. So from previous example tables, we understand that what R table values must be part of either R1 and R2. So these two are must be part of either R1 and R2. Hence, they are functionally dependent on one to another table. So they are functionally dependent on one to another table. So this is the way to understand that what dependency preserving. That means either the divided tables are at least one table has to be satisfied with the other table values, other dependencies values. So to do this, we need to understand one more thing, functional dependency. One more thing, functional dependency. So the functional dependency is a relationship that exists between two attributes. So the functional dependency is a relationship in between the both IDs and a name. So it establishes a relationship between two attributes. So ID is one attribute and name is one attribute. So it establishes a relationship between these two attributes. It typically exists between the primary key and non-key attribute within a table. Primary key and non-key attribute within a table. And that indicates that what x tends to y. So the left side of this functional dependency is what? Determinant. So and the right side of the production is known as dependent. So suppose here I can say that ID and name. So here ID and name. The name is what? Dependent. Because it is depending on ID. So ID is what? Determinant. ID is what? Determinant. So the dependent name is displays the values based on the ID. So for example, assume that we have an employee table with attributes called employee ID, employee name, employee address. Hence, employee ID attribute can uniquely identify the employee name attribute of employee table. So it is uniquely identified by the employee name attribute of employee table. Because if we know the employee ID, we can tell that employee name associated with it. So if we know the employee ID, we can tell that employee name associated with it. So the functional dependency can be written as what? Employee ID tends to employee name. So employee name is depending on employee ID. So here employee name is what? Dependent. Employee name is dependent. And the employee ID is what? Determinant. So we can say that employee name is functionally dependent on employee ID. So here types of functional dependencies. One is the trivial functional dependency, and the second one is what? Non-trivial functional dependency. So trivial functional dependency. So if A tends to B has a trivial functional dependency, if B is subset of A, the following dependencies are also trivial, like A tends to A, that means ID tends to ID, or name tends to name. So that means ID is depending on ID and name is depending on name. So that means it is a trivial functional dependency. and here B is a subset of A. So consider a table with two columns. Consider a table with two columns of employee ID and employee name. Employee ID and employee name. So employee ID and employee name, these two are the two functional attributes or trivial functional values. And here employee ID is a trivial functional dependency, as employee ID is the subset of employee ID comma employee name. So that indicates that what a trivial functional dependency displays what a trivial functional dependency. And also employee ID tends to employee ID is also a trivial functional dependency, and the employee name tends to employee name are also trivial functional dependency. So ID comma name, so a subset of ID comma name is depending, and similarly name is also depending. So at this moment we can say that what the ID or name are functionally trivial functionally depending on other attribute, trivially functional depending on other attribute. So there are two types of dependencies. One is what trivial functional and a non-trivial functional dependency. So till now we discussed the trivial functional dependency. So any of the attribute is depending is a subset of any value will be depending on that attribute. And the second one is what non-trivial functional dependency. Non-trivial functional dependency. If A tends to B has a non-trivial functional dependency, if B is not subset of A, not a subset of A. Suppose if you can take employee ID comma employee name, and the value is what employee salary, which is not a subset of this, So hence it is a non-trivial functional dependency. So A tends to B has a non-trivial functional dependency if B is not subset A. When A intersection B is null, then A tends to B is called as what? Complete non-trivial. A tends to B is completely called as what? Non-trivial. Non-trivial. So example, ID tends to name, and here this is non-trivial because name is not a subset of this, and here date of birth is not a subset of this. Hence we can say that what this is non-trivial. So at that moment we can go for the trivial functional dependency. So to validate these all functional dependency, we can use some certain type of rules. What are those rules? So inference rules are Armstrong axioms. We can say that what inference rules are Armstrong axioms. So how we are going to use these rules to validate those functional dependencies as a trivial and a non-trivial? So the Armstrong axioms are the basic inference rule. And these are used to concluding functional dependencies on relational database. The inference rule is a type of assertion. You can apply to a set of functional dependency to derive other functional dependency. So it can apply to a certain set of functional dependency to derive other functional dependency. Using this rule, we can derive additional functional dependency from the initial set also. So using this rule, we can derive additional functional dependency from the initial set also. So this is the way to apply the functional dependency, the way of applying the rules to functional dependency. So what are the rules that are going to perform? So the argumentation is also called as partial dependency. In this argumentation, if x determines y, then xz determines yz. xz determines yz for any z value. For any z value. So if suppose x is nothing but id, then z is nothing but any name, then y is nothing but any salary. So xz, that is a subset what id comma name tends to determines yz, that is nothing but y means employee salary comma z means name. So id comma name tends to salary comma name, so which is a dependency on this one. So that is validated, which is dependency on this subset, because employee name is a subset of these values. Employee name is subset of this value. So the rule is validated. The argumentation rule is validated. So first one, what? Reflexive rule. First one is what? Reflexive rule. So in the reflexive rule, if y is a subset of x, if y is a subset of x, then x determines y. X determines y. So if x determines y, so if x is subset of y, then it determines what? X tends to y. So take an example, x equal to a comma b comma c comma d, e y equals to abc, then x tends to y means the subset of y values are depending on x. The subset of y values are depending on x. The second one is what? Argumentation rule, that indicates IARE2. So the functional dependency has 6 types of inference rule. The functional dependency has 6 types of inference rules. So what are those rules? If x tends to y, then xz tends to yz. If x tends to y, then xz tends to yz. Xz tends to yz. So for example, relation of a, b, c, d. If a tends to b, then ac tends to bc. AC tends to bc. So the value of bc will be depending on value of ac. Value of bc will be depending on value of ac. Next one, transitive rule. Next one, transitive rule. So in this transitive rules, if x determines y, if x determines y and y determines z, then x must also determine z. X must also determine z. So suppose if taken x determines y, that means x is nothing but id and y is nothing but name. Then y name determines what? Salary. Name determines what? Salary. Then x must also determines, that means id must also determine salary, because salary is depending on name of the employee and the name is also depending on id of the employee. So now it is fully functionally dependent. Hence we can say that what? X tends to y and y tends to z belongs to x tends to z. So finally you can say that salary is depending on id. Salary is depending on id. Next, union rule. Union rule. So it says if x determines y and x determines z, then x must also determines y and z. So if x id determines what? Id determines name, and similarly x id determines salary, then x must determine both. Id determines what? Name comma salary. Name comma salary. So both two, name and salary, are both depending on id. Name and salary both depending on id. Next, decomposition rule. Decomposition rule. So it is also known as a project rule. It is also known as what? Project rule. It is the reverse of union rule. It is the reverse of union rule. So this rule says that what? If x determines y and z, if x determines y and z both, then x determines y and x determines z separately. So if x determines both y and z, that means employee id is determines both name comma salary, then you can write it as both id tends to name as well as id tends to salary. So that means salary is depending on individually id, the name is depending on individual id. So that means these two are depending on ids. These two are depending on ids. And last one, pseudo transitive rule. So pseudo transitive rule. If x determines y, if x determines, that means id determines name and y and yz. So z is nothing but salary, indicates that what? Id determines y, and then next yz determines w. So y name comma salary determines employee city, then xz, so that is nothing but id comma salary determines w, that is nothing but city. Id comma salary determines city. So that indicates that what if x tends to y and yz tends to w, then xz tends to w. So id comma salary, so city is depending upon the id comma salary, So this is the way we can use the rules to be validating, for the functional dependencies. So once again we revise the topic which we discussed in this session. So here the first is what is meant by decomposition. So why we are performing decomposition? So to when a relation is in relational model is not in appropriate normal form. When the relation is in relational model is not in appropriate normal form, then we must go for a decomposition process. So decomposition of relation is required. So decomposition is nothing but what? It breaks table into multiple tables. So splitting of one table into multiples. Splitting of one table into multiples. So if the proper decomposition is not performed, then the data will be losses. The loss of information will be occur. So there are two types of decomposition process. One is what? Lossless decomposition. The second one is what? Dependency preserving. One is lossless decomposition and the second one is dependency preserving. So lossless decomposition is nothing but what? If you are decomposing the tables, again if you join the two tables, then the data should not be lost. In the sense, then it is said to be lossless decomposition. So even though you are splitting the data will not be lost. So at that moment it is called as what? Lossless decomposition. So here we can use the table as a normal relation, and splitting that table into two types. After two tables splitting, again we are going to perform join on two tables. Then the resultant data will be the same. Will be the same before applying decomposition process. And dependency preserving. So dependency preserving is nothing but what? So at least one of the attributes from the relation will be depending upon the attributes of the another relation, then it is said to be dependency preserving. So for this, functional dependency will be occur. So what is meant by functional dependency? So functional dependency is nothing but what? Relationship exists in between the two attributes. So ID and name. So here name and ID, in between these two, and relationship will be existed. So here left hand side it takes as what? Determinant. It is treated as what? Determinant. And for the right side what? Dependent. Right side it is treated as dependent. So for this there are two types of dependencies will be there. One is a trivial functional dependency and the second one is non-trivial functional dependency. One is trivial dependency and the second one is what? Non-trivial functional dependency. So trivial functional dependency is nothing but what? The ID from the left side, the attribute from the left side and the attribute from the right side. If attribute from the right side is depending on attribute from the left side, then it is said to be non-trivial functional dependency. So to do this, to validate these all functional dependencies, we are using some different types of rules. What are those rules? We can call it as inference rules. So they are concluding both what? Functional dependencies on relational database. They are concluding what? Validating functional dependencies on database. So first one is what? Reflexive rule. So reflexive rule, the right side of values will be having a subset of left side values. And the second one is what? Augmentation rule. So here if x tends to y, then xz tends to yz. It is called as what? Augmentation rule. And a transitive rule, if x tends to y and y tends to z, then X tends to Z says that what? It is a transitive rule. And the union rule. If X tends to Y and X tends to Z, then X tends to YZ both. It is called as what? Union rule. And decomposition rule. If X tends to YZ, then X tends to Y and X tends to Z, then it is called as what? Decomposition rule. Decomposition rule. And last one, pseudo transitive rule. So pseudo transitive rule, if X determines Y and YZ determines W, then XZ determines W. XZ determines W. Then if X tends to Y and YZ determines W, then XZ determines W. So these are the rules that are validating the functional dependencies of attributes. These are the rules that are validating the functional dependencies on the attributes. So that is all about to relational decomposition process. So decomposition process is compulsory to say that the relation is in normal form. Say that relation is in normal form. So to do this, we have to do all these things. So relational decomposition process, transitive dependencies, non-transitive dependencies, functional dependencies, and the inference rules are applied to validating this uh, decomposition process. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.